Alright guys, welcome to this page of the notes. We're going to go ahead and do a couple more problems just to get a little more practice when it comes to solving a quadratic inequality in one variable, which means finding the solution intervals, or all possible values of x that satisfy the inequality. Well, the way that we're going to do that is I'm going to solve the related quadratic equation. So 0 is equal to x squared minus 2x minus 35. I believe that I can factor this as a general trinomial. My leading coefficient is a 1, so it's going to be an x and an x. Then I need two numbers that multiply to a negative 35 and sum to a minus 2. Well, you may need to do a little bit of, guess and check, but hopefully you can pretty quickly come to the realization that to get 35 would be a negative 7 and a positive 5, right? Because 7 times 5 is 35. But it would need to be a negative 7 and a plus 5, because when you add them together, negative 7 plus 5 would give you your minus 2. So negative 7 plus 5. Well, zero product property lets me split them up. And again, when I say graph, I know it's misleading because I gave you a coordinate plane. Ignore the coordinate plane. I should have given you a number line. I apologize I didn't. That's okay. Draw your own. We'll put the negative 5 down here. We'll put the positive 7 up here. And now all I need to do is choose some test points, right? Stuff that's easy. Like maybe 0, 8, minus 6. And start plugging that stuff in. If I do 0, that would be 0, that would be 0, and I wind up with negative 35, right? So I have 0 is less than or equal to a negative 35. Well, that's not true. Oh, sorry. That's false. Right. What about 8? Well, 8 squared is 64. Negative 2 times 8 would be a minus 16. Negative 16 and 35. Sorry, here we go. Real quick, I calculated. We're going to do 64 minus 16 minus 35. You wind up with a positive 13. And 0 is less than or equal to 13. So that gives me a true statement. Since it's less than or equal to, it's got to be a closed circle and everything going in that direction. And you can go ahead and check it if you want to, but since this was true, this was false, this guy's got to be true. Let me show you. If I plug in a negative 6, negative 6 squared is 36. Negative 6 times a negative 2 would be a positive 12. So I wind up with 36 plus 12 minus 35, which comes out to be 13. Closed circle. Everybody headed in that direction. And again, you're going to write your answer, which is in interval notation, all values of x such that x is less than or equal, oh hang on, that's a terrible less than or equal. Less than or equal to a negative 6 or greater than or equal to 8. And then close it with a bracket. That wasn't a very good bracket. There we go. All right, I got one more for you here. Let's see how this one goes. Again, it's an inequality in one variable, so I need to solve 3x squared minus 7x minus 1. All right, I'm factoring a general trinomial, but instead I'm going to do the slide and divide method because my leading coefficient isn't a 1, so the slide and divide method will hopefully work. Let's see. Remember, the slide and divide method works by sliding the 3 over and multiplying it by the value of c. So that gives me x squared minus 7x minus 3. Now what I'm looking for, because my leading coefficient is a 1, I need two numbers that multiply to a -3 and sum to a -7. And you can search and search to your heart's content, but there are no such real numbers that multiply to a -3 and sum to a -7. No real numbers. Multiply to -3 and sum to a -7. It's not possible. It's not possible to have two numbers that will multiply to give you -3 and then add together to give you a -7. It doesn't happen. Can't happen. So what that means is that for this particular inequality, there is no solution. Right? No solution. Right? So that's what it means if you're not able to factor it. This quadratic does not cross the x-axis. In fact, it's going to be a parabola that is somewhere up here, opening upwards. And I've asked you to find all of the values. I asked you to find all the values where the parabola, right, the quadratic, is less than or equal to 0. Well, that's not possible. My entire parabola is above the x-axis. Everything is greater than 0. This guy is never less than 0, right? Because the whole thing is above, right? Right here is my x-axis. This represents my 0, right? That represents 0. And I want to know, when is the quadratic below 0? When's it less than 0? Never. Right? That's why it's no solution, right? My quadratic, my parabola is above the x-axis, opening upwards. It'll never be below the x-axis, so I have no solution. Guys, that takes care of all the problems in this section of the notes. At this point, you should be comfortable both with graphing a quadratic inequality in two variables and shading the solution reading, so graphing and shading. That was the first objective. And then the second objective, where you solve a quadratic inequality in one variable by writing the solution interval. And please remember, the best way to do that is going to be by graphing it on a number line, and then just use the number line to write the interval notation. So when I say graphing, I'm not actually talking about graphing on a coordinate plane. I shouldn't have given you that. You'll just use a number line. Guys, thanks so much for joining me for this set of videos. I had a great time doing quadratic inequalities with you. I'll see you guys next time.